I'm Ashley Broderick, and this is the Lab 2 Lines of Charge lab report. So, to start with an introduction and the fundamental principles that go along with this, um, the goal was to model two charged tapes exerting an electric force on each other, and this was using Coulomb's law. And in a model in which one tape is floating above the other, that was achieved through Newton's second law. And to estimate the amount of charge on each tape necessary to achieve the state of floating with evenly distributed lines of charge, and that would be with using superposition. So in this report, we'll go through the model and the data and then the coding that was used to find a new estimate of the charge on the tape using a line of charge instead of a point charge. So in the model, the real system is two evenly distributed lines of charge interacting, and this was recreated with two pieces of charged tape. The top tape was considered the observation location because this was the tape with no momentum, so that goes back to the Newton's second law, and both tapes were considered lines of charges. The electric field is a true system, and a true system was more easily observed in the model as a bottom tape changed position due to the electric force. For the data and measurements collected to do this lab, the length of the tape was 2 meters or 0.2 meters. The mass was 0.0002 kilograms. The distance between the tapes when floating occurred was 0.0275 meters. The magnitude of gravitational force on the tape and electric force on the tape were equal at 0.00196 newtons, and this is because there was no momentum. And the magnitude of charge that was found in lab 1 was 1.3 e to the negative 8 coulombs, but in this lab, it was found to be 0.651 e to the negative 8 coulombs. And the coding, this is the image that was achieved. The magnitude of charge on the one piece of tape, like I said, was found to be 0.651 e to the negative 8 coulombs. And this is with the assumption that you're ignoring air resistance on a moving object and assuming that each U-tape has the same amount of charge evenly distributed along the length of the tape. And this is just a sample of some of the lines of code showing the electric force and iterating through to find the pieces of charge in each tape. And then the questions, if the tapes were modeled as a single point charge like the previous labs, and why do these values differ? Which is more likely to be the real value and why? So in lab 1, the charge was found to be 1.3 e to the negative 8 coulombs compared to 0.651 e to the negative 8 coulombs as it was estimated through the lines of charge. There's a difference because in treating the piece of tape as a single central point charge, that's a gross oversimplification of what's actually happening. Really, the entire tape is made up of charges, so a line of charge estimate is more accurate, and that is what we're using as the more accurate estimation. So in conclusion, there was a difference between the charge estimates in using a point charge estimate and a line of charge, but the line of charge should be more accurate because it's a closer model to the real system.